I'm getting a little sick of streaming services.
I feel that. I feel that in my soul.
Yeah, yeah, I'm getting kind of a lot sick actually of streaming media services. There's kind of shenanigans going on with their prices going up.
Yeah.
So like I think I pay about 150 bucks a month
Mm-hmm.
in all of our streaming services.
Yeah.
I stuff that was there has been removed. Like Westworld, you can't get
I
Westworld
know that one
from
pisses me
HBO
off.
anymore.
Yeah.
Because
It was
it didn't go where they wanted.
beautiful.
Yeah, and then they get a tax write off, but all of the people who worked on it are just boned. So there's that. And then there's this kind of the stuff you want to watch
Yeah.
isn't available.
Yeah, I hit that a lot.
Instead, there's this kind of just middle layer of stuff that you can watch.
Yeah.
And I've got a bunch of tools that I use. There's a service called Just Watch, and then there's Letterboxd, and you can sort of then build lists and find stuff, and then you can sort of go, oh, here's this movie, everyone's recommending it. Oh, and it's actually on Prime Video. It's just obscure. It never would have surfaced it to you.
Right.
And but I'm finding that all of this stuff is also available at my library.
Oh,
So
that's cool.
we have kind of an amazing library system here on Vancouver Island, where they have like 26,000 DVDs and Blu-rays in their
Oh,
system,
jeez.
and then you just put in a hold, and then they will move heaven and earth to get that disc into your hold
Local.
area, and then you go into the library and you pick it up and it's free. And so I've been noticing how many good movies are just sitting there on that nobody does this anymore. Nobody actually goes and watches DVDs or
That's
Blu-rays from the
amazing.
library. And so, for example, Deadpool versus Wolverine is in at the library, and there's a stack of 5 of them at just my one small branch of the library. They've got about 50 copies of it in the system, and it's just okay, right? Like I'll watch that, right? So that's the upside is that pretty much every movie that you could ever want is
Uh-huh.
either in the library or in their they have a streaming service that's associated
Yeah.
with it called Canopy, and this is probably available to most libraries. And you just can watch the movie through. You get like a certain number of credits every month through your library pass, and so I've got mine. My wife's got hers, and so together we can watch pretty much as many movies as you want, and you can watch just the best movies ever made from history. And so between the library and that, so that's the upside. The downside is that generally it's DVDs,
Yeah,
right?
so it turns out I can do the same thing with my local library.
Yeah, yeah. And so the DVDs are lower quality,
Yeah.
but the upscaling on modern TVs and modern DVD players is actually pretty good. And so it's a little soft. Like after you've watched the DVD, you're like, oh, all the lines are so nice and crisp. It's like a little soft, but at the end of the day, the movie is the movie, and you watch it and you enjoyed it. And so, and then when you watch something like a proper Blu-ray that you've
Yeah.
actually put into the little disc player, it's actually much higher quality than often the streaming system. So yeah, so I bought one I went to a thrift store and I picked up
Yeah.
Blue Planet as more of
Oh, the
as a
BBC?
calibration. Yeah, just as a calibration, just to see like how good can it look with that. And then my DVD player can also handle UHD, the ultra high
Oh.
def, which is the 4K DVDs.
Do you have a
So
TV that handles that?
yes. Yeah, we've got a 4K TV. Don't you
Okay.
have a 4K TV?
No.
They're
I have 4K
Oh, okay.
monitors.
yeah. 4K TV can play the ultra high def media.
Okay.
So, but so I think like I'm sort of like, can we just exist on me once a week picking up a stack of DVDs and bringing
Yeah.
them home and setting them beside the TV? And they also have all the TV shows as well. So if I'm like, oh, I really want to
Yeah.
rewatch whatever Stargate, then you can just pull the DVDs out of the library as well. So I'm just kind of flirting with it, just
Yeah.
sort of feeling kind of annoyed and overwhelmed by and the continued enshittification of the streaming services.
Yeah, yeah.
So Right. And this is like, we haven't seen nothing yet. I mean, they took away extra logins for my kids. They took, you know, the prices just keep cranking up. So anyway, that's sort of and like, even if you just like, you know, I'm just going to buy the media that I would watch.
Right. I do that a lot.
$150 actually goes really far.
Yeah.
When you are pulling DVDs out of,
Yeah.
you know, garage sales, thrift stores, bulk lots, whatever. Right. So yeah, this is just sort of just this new flirtation that I'm having, but I also have to balance that with my sort of hatred of atoms. And so the library feels like it's the right way.
Yeah.
You just you pick them up from the library, bring them home, you stack them up, you watch what you did, you watch what you watch over the course of the week, and then you just return them. And then you have a clear conscience. Like you didn't get around to them because you didn't get around to them, right? They weren't compelling enough. So,
but before the iPhone came out, I used to, or I guess it was actually the iPod came out. I used to get audiobooks at the library, and they got me through graduate school because driving back and forth from the observatory and then observing all night, and at a certain point your brain is no longer capable of doing things that are sophisticated. So listening to an audiobook, I went through just about everything at one library, and then I went across town to a different library because it was easier for me to move myself.
yeah.
I then got into the habit of just buying audiobooks because I re-listen to them. One of the nice things about listening to things while slightly distracted is they don't go into your long-term memory as solidly, so you can re-listen to them 3 years later and it's a new book.
They have tons of audiobooks at the library. They have an audiobook streaming service you can use as well.
I've used that.
Yeah. It's kind of amazing. And so like libraries are already under threat.
Right.
And so my thought is like, if we reuse the library, then maybe more people will use the library, and then we can sort of have more funding go to libraries and sort of move into the system. Anyway, Helm McKinney asks, and I like this is just bait. I gotta take it. Any thoughts on Tilly Norwood, the AI actress? So have you heard about this at all?
I have, and I hate everything about it. Everything.
So I think it is fine in one way.
Okay.
Which is that somebody has gone and like has put in all the time and energy and effort to make this thing, and then is going to have to manage all of the, this Lovecraftian monster.
Yeah.
And then it's going to have to manage and deal with this and all of the technical issues and all of the times when it goes off script and all the times that it isn't consistent and coherent and is generally worthless for the needs of a director who is trying to manage a consistent media experience. And so this is going to be more than a full-time job. This is going to be much, much harder than just hiring an actress.
Right. It's true.
Right?
It's true.
Yeah. And so I think that whoever is doing this is purely a media stunt, and it's going to just like demonstrate how important actual human actors are to this process. So I think this person is doing a service by reminding us how valuable still having humans in the loop is going to be. So yeah, that's my take on it, is that it's going to just fail miserably in humiliating and hilarious ways that the media companies aren't going to touch with a 10-foot pole, and set back the whole process of it for a long time. So yeah.
I keep thinking about all the interviews with Ewan McGregor where he talks about how he doesn't really remember filming the last two of the prequels because he was working with green screen so much that it just didn't put him in the experience. Yeah. And when you're working with these virtual actors, you don't have a human being in front of you to play off of. You can't reach out and touch them the way you might with an actual human. Yeah. I on one hand, I'm like, well, the next step from this is they're just going to start creating entirely digital content. They're going to flood the market, and the enshittification is going to continue. But then the other thing is like, can you imagine being the person who's early in your career and you just needed a job and now you're trying to act against a virtual critter?
Well, people are just, as you say, people are going to make whole movies. Like, they're just going to
Yeah.
make whole movies, and they're going to suck.
Yeah.
So, like, don't worry about it, right? Because they're going to be so terrible that people are going to crave an actual human. Do an experiment for me right now. Open up an incognito tab in Chrome,
Okay.
and then go to YouTube and do a search for Comet.
Hold on.
Or if you really want to push this to the limit, and maybe everyone's watching this can do this as well. Let me try.
What? So
YouTube.
I'm just Google
it's-
Comet.
Yeah, just Google Comet.
Oh, I forgot to go to YouTube first. That got me the New York Times.
What is your top? What is your what is your top story? Is it the
Earth
first close
in
image of?
big danger. 3
Oh, okay.
comets coming near Earth this year.
Oh, I see that one too. Yep. Okay, great. So now just do a search for space. Let me see if it will keep it. Yep.
This one got me naked science. 3 hours of jaw-dropping space facts to fall asleep to.
Okay. And then?
Then I have a bunch of shorts, and then I have what appears to be some weird set, and it's astronomy definition, K through 8 science, fun
Okay.
videos and lessons.
So you're not seeing the slop.
No, and I think it's because incognito isn't as incognito as you'd like.
I mean, maybe it's too late because we already did the comment search, but in general, if you watched one of them, then you get the slop. So pretty much any space related thing that you search for on YouTube now, you just get slop.
Yeah.
And so I'm like, I know I rant about this every week, but YouTube is just making itself just a garbage dump.
Yeah.
And so people are going to be wondering how they can watch good stuff. And
Patreon.
So
seriously. So
yeah, Patreon or just
Yeah.
whatever. You're going to find creators. You're going to subscribe to creators. You're going to give up on the algorithm. So anyway, that's where we're at.
So folks, if you haven't gotten the Patreon mobile app, they've added this new feature called Quips that allows you to scroll in a relatively doom-free environment. I mean, there's people who are doing artwork of hellscapes in Dungeons
Right.
and Dragons, but
Yeah.
in general, it is a really good way to just fill your brain with content when you need that dopamine. It does for me what Instagram used to do before the algorithm stopped showing me just what I was following.
Yep.
So yeah, check out the new mobile Patreon app, and yeah,
They need a TV app.
they do.
So a bunch of people have been complaining
Yeah.
that the problem with Patreon is you can't watch it on your TV.
Yeah.
And it's a huge problem. I'm going to nag them. Okay, let's get started.
All right. Okay, I need to press record. This is 767. Hello. Okay, that is recording. That is recording. All the things are recording. I'm going
Okay.
to move my necklace to the back before it does something catastrophic.
Right. And your hair.
Yeah.
Actually, you're not using that microphone on your. Are you using the microphone on your?
Using this one in the center. Yeah.
Okay,
I'm living
there we go.
dangerously.
Astronomy Cast, episode 767 Black Holes in Extreme Circumstances. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos. We hope you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmQuest. Hey, Pamela, how you doing?
I am doing well. Before going live, we were discussing all of the evils of AI slop in YouTube, and I'm giggling at the stuff that the people watching this live are now dropping into the chat.
Yeah, they're digging up slop titles for different searches on YouTube. Yeah.
So,
yeah. Like, audience, do this for yourself. Go to YouTube, open up an incognito browser, so it's one that doesn't have all your cookies in it, doesn't have any of your history. Go to YouTube, search for Comet, or Space, or James Webb, or Asteroid, anything like that. And then just enjoy the slop that is the first thing that a person who is freshly arriving at YouTube is experiencing. It is a nightmare.
And always like and comment on the stuff you love.
Well, like that'll help.
Well, I can pretend.
Yeah. Yeah. You can only describe a black hole by its mass and its spin, and maybe its charge, but allow us to propose a new criteria, their personal experience. Some black holes have seen things, experienced the laws of physics at their most extreme, and today we'll tell their tales. And we'll talk about it in a second, but it's time for a break. And we're back. All right, this is going to be one of those episodes where you have dug up a whole bunch of interesting, extreme black hole stories, and I am just going to prompt you one after the other, because although I've probably reported on all of them, I don't know in advance which ones you're going to want to talk about, but hopefully I will be up to speed the second you relay a few quick comments. All right, so we're going to talk about black holes that have seen things.
So this all got inspired by the star that made the horrible mistake of eating its black hole companion.
Right. Yeah.
This is a system that started out with two truly enormous stars. The smaller of these two stars was 30 solar masses. The larger we're not sure because mass loss is a thing. But whatever size it was, it ended up producing a 10 solar mass black hole. So we have a massive 30 solar mass star, a 10 solar mass black hole going around and around each other.
Oh, I didn't start my recording.
Oh.
We've got to start this whole thing all over again.
Okay.
I apologize in
Stopping my
advance.
recording.
Or did my recording crash? I don't know. Okay.
Okay, hold
Let's
on.
start again.
Started that. All right.
All right. Let's try again. Okay. Astronomy Cast, episode 767, Black Holes in Extreme Circumstances. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we open... Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. I'm trying very hard not to burst out laughing at all the stuff our audience members are sticking in the chat.
Yes.
Because right before we went live, we were talking about AI slop, and some of it is so bad, you
Yes.
can laugh or cry, and I usually do both.
Yeah, the recommendation that I make is go open up Chrome, open up a new incognito window, go to YouTube, do a search for whatever space topic is interesting to you, comets, space, James Webb, whatever, and you will see the sloppiest slop that ever slopped. And it is just like, this is what YouTube is now showing to people when they come to their website, and not more legitimate science.
Yeah.
So what are you going to do? You can only describe a black hole by its mass and its spin, and maybe its charge, but allow us to propose a new criteria, their personal experience. Some black holes have seen things, experienced the laws of physics at their most extreme, and today we'll tell their stories. And we will talk about it in a second, but it's time for a break. And we're back. All right, you've got a bunch of stories queued up that are extreme black holes experiencing extreme experiences. What's your first one?
So this is my so far favorite story of the year. A young 30 solar mass star was hanging out with its more massive previously sibling and made the mistake of consuming its sibling, which was a black hole at this point.
Right.
So
what was the sort of series of events that led up to this, I guess, unfortunate mistake?
Right. So the two stars were born with very different masses. The one started its life with about 30 solar masses. The other one was significantly larger. We're not sure how much larger because mass loss is a thing. But however big it started out, it ended up making a 10 solar mass black hole. So we have a binary system with a 10 solar mass black hole and a 30 solar mass regular everyday star, and due to drag forces they were getting closer and closer to one another, and the 30 solar mass star made the unfortunate mistake of consuming that 10 solar mass black hole, which led to the black hole rapidly feeding on the contents of the star
Right.
changing in brightness over time, and ultimately the core of the star and the black hole together triggering one heck of a weird supernova. This object is supernova 2023 ZXD. When they looked at its light curve didn't behave over time the way you would expect. They went back through archival data, saw that the system had been brightening over several years, and the research paper that came out of this is a spectacular example of, could it be this? Probably not because of this. Could it be this? Probably not because of
Right.
this. As they work through idea after idea, and the thing that fit was star eats black hole, which is the opposite of what we're used to. But at 30 solar masses, it was definitely the dominant player in the system.
Yeah. Yeah, I think our title on Universe Today, the story was Star Eats Black Hole and Instantly Regrets It.
Yeah, we had very similar for EVSN. It's
Yeah,
my favorite
yeah.
story this year. Maybe my
Yeah.
favorite in many years. It's
Yes.
just gloriously wrong.
And so what do we think would have happened? Like, we back in the day there was the star with 30 times the mass of the sun, and then there was a much bigger star. It died first because the more massive you are, the shorter your life.
Right.
Detonated as a supernova and left a black hole remnant, and
Yeah.
now you've got this binary star system. And then the two got closer and closer and closer until the black hole went into the star?
Yeah, that is exactly what happened. And it all comes down to the fact that, yeah, the black hole was definitely nibbling on its companion as frictional forces brought them closer and closer together. But once it's inside that atmosphere, it's definitely a merger event. And it's definitely the blue star, which has gotten stirred up and bloated out a little bit, doing the consuming. And while that black hole inside the 30 mass star is going nom, 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 nom on everything around it, it took time for the core and the black hole to merge and explode as a supernova.
And what caused the explosion? Like, why did it go supernova, and why did the black hole not just gobble up the star from within and disappear it?
It all comes down to the rates at which things can happen. So the 30 solar mass star, which was no longer 30 solar masses, to be clear, mass loss also did it in. It had a core that was already fairly evolved. It was already on its way to going supernova at some point in its future. And the black holes simply accelerated the process. So the black hole itself couldn't eat all of its surroundings fast enough to prevent a supernova. What it could do is begin that core collapse process that prevented further nuclear reactions from going on. A star is carefully balanced between gravity trying to compress the entire situation, light pressure pushing out, trying to keep the star being a star. But the second you don't have all the nuclear reactions you need going on in the core, the outer layers of the star are no longer supported by light, and they're going to collapse down. As they collapse down, the higher densities that they get, just because they're now becoming a crumpled ball of star, those higher densities allow new nuclear reactions to go on, which explode out light, creating the supernova we see. So it's this process of you kill what's going on in the star's core. Car, I guess, is what my brain can press that to.
Yeah.
You kill what's going on in the star's core, the light shuts off, everything collapses, generates new light that supernovas out the outermost layers, while the core collapses to form whatever it forms in the end.
Okay. Well, we're going to talk about another bizarre black hole experience, but it's time for another break. And we're back. All right, what have you got next?
Oh man, there are so many different things to choose from, and I'm just not going to get through nearly as many as I wanted. So I'm going to talk about LID 568. This is a black hole in a dwarf galaxy that is feeding at rates a star should not be feeding at. So there's this thing called the Eddington limit, and it is how we say black holes should be limited in what they should do. The idea is that as material tries to stream in, it gets hot, it gets dense, it generates light. This is a recurring theme in the universe. That light then pushes out the material, preventing further infall, cutting off the feeding frenzy the black hole is experiencing.
Right, and this is the same kind of limit that we see with stars.
Yeah.
That is, we don't see stars that have 1 billion times the mass of the sun.
Exactly.
We see stars with about 100 times the mass of the sun at the most, and that's because as they get bigger, hotter, more radiation, at a certain point, they're just blowing away any other material that's going to try to fall into them, and they just can't get any bigger. And black holes can do the same thing with the accretion disk that builds up around them.
But for reasons that my read-through of the discovery paper didn't see an answer to, this thing is feeding at 40 times the Eddington limit.
Right.
And so suddenly we are discovering that black holes are capable in some circumstances of consuming material much faster and more thoroughly in a rapid, sudden epic of growth than what we had expected. And researchers are actually thinking this particular star got all grown up in essentially one massive feeding frenzy that broke the limits we previously attempted to put on these things.
Yeah, there was a couple of interesting things about this story. So they said, using this idea of the Eddington limit, they said, well, if you sort of rolled this black hole back to the beginning of, like, when it formed shortly after the beginning of the universe, it would have had to have formed from a star that was about 10,000 times the mass of the sun, was one option.
Yeah.
The other option is that it was a direct collapse black hole, that it just went straight into, from cloud of gas and dust to black hole, and then grew from there. And those would help you explain a black hole that you saw with this kind of size. But the sort of really interesting idea is that there's these, that there are ways that black holes can maybe cool themselves down.
Yeah.
That they can actually allow inflows of material that gets around this Eddington limit by artificially cooling the regions around them as well. So there's a lot of, obviously the universe can do things that are weirder than we had ever anticipated. And this just shows, like, your theories are great, but at a certain point, reality has some lessons to explain to us.
And this idea that black holes can form at masses that a stellar mass star going straight into a black hole can't explain is something that comes up over and over again. So another example of things behaving weirdly is a LIGO discovery, GW231123, which is beautifully symmetric. This particular paper had 10.5 pages of authors. I just want to call out, collaborations are amazing and sometimes eat a lot of paper, so don't print those things out. This particular merger was between a 103 and a 137 solar mass black hole. So this is two intermediate mass black holes merging together into a larger intermediate mass black hole. And the thing about this is both of the black holes that went into the merger fell in what was supposed to be a gap in black holes formed through stars. What happens is, as a star gets bigger and bigger and bigger, it eventually reaches the point where the core completely combusts the entire system. This pair instability means that at lower masses, sure, it collapses down, has a black hole in the core. At higher masses, it can overcome this, sure, collapses down, becomes a black hole again. But in this gap, when it tries to do that, the helium in the core is like, I'm not going to have anything to do with that. And it explodes completely. So here we have a system.
And there's like no remnant, no black hole,
there's
nothing.
Nothing left behind, all gone.
Puff. Yeah.
And here we have a system with two stars, two black holes, that both fall into the black hole mass gap. And the question becomes, were we completely wrong on the mass gap? Is there another mechanism for forming black holes? Or is this a statistically improbable system that was able to go from two things that formed black holes that merged, two things that formed black holes that merged, and then those black holes merged to get this eventual outcome? And the statistics on how hard would it be to get that double black hole binary system that forms, so you start out with a system of 4 black holes and then you ultimately end up with 1. How difficult is that? And it's not entirely improbable, but it's at least 25% possible and 75% improbable. So probably not. We're learning black holes do not follow the rules, people. They do not care.
And we talked about a similar story, I feel like within the last year, same situation. Although one of the black holes shouldn't have been. The other one was fine, but one of them was in that mass gap. And so the fact that we've seen now 2 of them, maybe more, I'm not sure exactly how many LIGO has seen, is showing that either this theory that black holes aren't formed from this certain mass of black holes, or that there's some other mechanism. And the one that's really exciting, which would also explain the previous story, is that you have primordial black holes. So you have black holes that were formed early on in the universe of any mass. Some that were the mass of an asteroid, some that were the mass of 1 billion times the mass of the sun. And then you can have any mass you like be able to meet with each other and merge, and you're not dependent on that process of stars forming bigger, black holes meeting other black holes, and eventually building up that chain of events to get the kind of collisions that we're seeing.
And this is one of those things where, again, I think the answer is going to be both. That we're going to realize that, yes, there were primordial black holes, and there's no other really good way to explain all the stuff JWST is finding in the early universe. That we're going to realize that in many cases, you have giant blobs of material that collapse straight into a black hole thanks to turbulence and other cooling factors that are able to take place. Mm-hmm. It's just like what we've found with galaxies. It used to be that people thought we were going to one day realize that it was either a hierarchical merging of smaller systems into progressively larger systems, or that it was clouds of gas that collapsed down into the size we see generally. And it turns out the answer is both. That early in the universe there were massive elliptical galaxies that formed, but there were also hierarchical growth that led to things like spiral galaxies we live in.
All right, we're going to talk about more extreme black holes, but it's time for another break. And we're back. All right, what's your next example?
So we've been talking a lot about massive black holes because, I mean, we all love massive black holes, but we're starting to find small black holes. Now, neutron stars can't, for questionable values of can't, be larger than 2.25 solar masses, because above that, the neutron degeneracy pressure can't support the star and it collapses. Now, there's always people who are moving that limit up or down by tuning different parameters in the system. But around 2.25 solar masses is where the limit in the size of neutron stars is. And in looking at stellar mass black holes, there appears to be this gap where there's like nothing around 3 or 4 solar masses, and it's not entirely clear why there's nothing in this particular mass range. But we're starting to find smaller systems. One of these is G3425. It has a mass that looks to be around 3.8 solar masses. It's definitely beneath 4 solar masses. And it looks like part of the way it got that way was through having jets. So we need to figure out, how do you take a truly massive object, have it collapse, leave behind only its core, and in the process shed enough material that you end up with just the right size of a tiny core.
Wow. And so was this happening like as it was forming?
Yeah.
Or
yeah.
Very cool. I've got a story up here, and
Okay.
and let me know if this is in your list.
Okay.
GW190412, the recoil event.
No, that one I don't have. Tell me more.
Well, all right.
The universe is big.
Yeah. So this is a black hole that was discovered in 2019 between two black holes. One was 8 times the mass of the sun. The other one was 4 times the mass of the sun. And this is one of the largest discrepancies in masses between two black holes. You had one that was double the mass of the other one.
Yeah.
And so the question that the astronomers were wondering was, would you get a recoil? Would you get a kick because you had this big difference between the black holes? And so they were able to sort of carefully examine the collision in the LIGO data and determined that, yes, indeed, after these black holes came together, because their masses were so different, it was kind of like a thruster on the side of the finished black hole that then gave it a kick at about 50 kilometers per second.
That's cool.
To the side. So it was just because it was asymmetrical, as the black holes came together, then you got this kick, this recoil, and it happened inside a globular cluster. And so the recoil was enough to kick the black hole out of the globular cluster. And so one of the big expectations is that the place to look for intermediate mass black holes is in these globular clusters, that you've got a lot of stars that are very close together. A lot of them were massive. They died, became black holes merged, and so on. But they have found a few, but not as many as that they were expecting. And so now, maybe, over the course of enough time, a 50 kilometer per second kick is going to push your black hole right out of your cluster. And so it might be that these black holes, they're forming, if they're not exactly equivalent masses, you're going to get these kicks. These things are going to be spat out into the larger galaxy. And a lot of these globular clusters are outside of the plane of the galaxy. And so they're just spat out randomly into the universe.
Conservation of momentum is a bear. This is literally the black hole equivalent of what happens when, don't do this with human beings, your AI-driven three-wheeler collides with your AI-driven SUV, and you end up going primarily in the direction of the SUV's mass.
Yeah.
And
Yep.
Okay, that is impressive. So let's look at the other extreme. This is my favorite discovery story of a black hole. It wasn't behaving badly, it was just behaving bigly, to use a word that I shouldn't.
Extremely?
Yeah. So
hugely.
Its distance is 5 billion light years. Its mass is 36 billion solar masses. Yeah. And it's in the cosmic horseshoe galaxy. And what was happening is this really massive galaxy was getting used to study gravitationally lensed background objects. And they were working to try and deconvolve what's going on with all these gravitationally lensed things and use the Hubble Space Telescope to do some very sophisticated observations of the core of the galaxy. And it was enough to be able to measure the motions of stars and gas down in the core of the galaxy and get the mass of the central black hole. Normally you can't do this with any but the closest of the massive galaxies, but this black hole is so unbelievably large that even at 5 billion light years, they were able to use spectroscopy to measure velocities, and it's just awesome. Accidental science is the best science sometimes.
Yeah, and I think a lot of people who are listening to this episode, you're familiar maybe with TON 618, I think is the name of the black hole. And that was largely considered the most massive black hole that's ever been seen in that same kind of region.
Yeah.
And now it looks like this new cosmic horseshoe is a serious contender, perhaps the winner of the most massive, supermassive black hole in the universe that we've ever found.
It's definitely the winner of the best discovery story for a massive black hole.
Right. But it is a contender for the most massive, the biggest. You know, check the Guinness Book of World Records shortly, and that might be the black hole that's in there. So, what else you got?
So that was really my list of favorites. The star eating the black hole. I mean, there's a few others out there. Chandra found IGR J17091, which is a contender for being the smallest black hole. It's somewhere between 3 and 10 solar masses, looking closer to 3 than to 10, but they don't have enough data to say for certain how tiny it is. And I just want to point out that we are now looking at things that are ranging from between IGR J17091 and G3425, which are both down around 3 solar masses, and then the cosmic horseshoe galaxy central supermassive black hole, 36 billion solar masses. We're looking at roughly a 10 billion solar mass factor, like multiplier of 10 billion between the smallest and the largest we've seen so far. And there's absolutely no physical limit on how small or large a black hole can be. The only limits are, how do you form it?
Yeah.
And this is where, to get the small ones, we need to master mass loss. To get the biggest ones, we need to master mass inflow. And physics likes to break both of those things. And so primordial gets us, okay, so what leftover small things are floating around our universe?
So speaking of that,
yes.
I've got one last story then before we close this out, and this is a prediction. So this idea of primordial black holes, we brought this up earlier. If these things are out there, then they could have been formed at any mass, and the smallest ones, the least massive ones, will evaporate and have already evaporated. And so there is a sort of the smallest possible black hole in the universe is the one that is about to evaporate.
Yes.
And so people have done some calculations, and that if this is happening, our modern neutrino observatories should, with about a 90% chance, detect the presence of this last gasp. When a black hole evaporates, you get this sort of burst of high energy radiation, neutrinos, and that we now have detectors that are sensitive enough to find this. And so within about a decade, if this actually happens, we should detect the burst of a black hole evaporating. And so that'll tell us whether or not these primordial black holes exist.
And the only thing we have to remember is this could very well be like all the predictions of protons evaporating, or not evaporating, decaying, where we have these theories that say this thing should be happening, and then we just never see it.
Yeah.
And this is the reason we keep doing science, is we are building a picture of a universe that, when we create our science, has to conform to everything we know is in the picture. It makes predictions about things that haven't been seen yet, but until we see everything, which we're never going to be able to do, we can't fill in all the details. And we're going to periodically be wrong, and that's kind of awesome, because that means there's new physics waiting to be discovered.
I'm sure this will not be the last time we've done an episode that is about this kind of thing.
Yeah.
We're going to find exoplanets, black holes, galaxies, things doing extreme things. Thanks, Pamela.
Thank you, Fraser. And thank you so much to everyone out there who is watching us live, and especially thanks to all of our patrons. And this is where Rich now inserts the audio I recorded yesterday so that I could take multiple takes, because there are more of you now, and your names are wonderful but difficult, and I still mispronounced them. But you have to go listen to the finished audio to hear the names.
Sounds good. All right. Thanks, Pamela. We'll see you all next week.
Bye-bye. All right. And then they saved. So yeah, if you are one of the people who listen to us on Patreon, your name is either in the description of the YouTube, in the audio I've already recorded, and I updated the names on Astronomy Cast yesterday. We are still struggling under the onslaught of bots. I'm still waiting to hear if we get nonprofit, and I'm starting to look at apps that will convert your WordPress over to a static site. I hate everything.
Yeah. Okay. So I've uploaded.
Okay.
So let's take some questions. Helmikini asks, how is it that magnetic field lines are able to escape the inescapable gravity of a black hole?
They don't.
Yeah, they come from around the black hole.
They're coming from the accretion disk.
Arjun, would LIGO catch something like this, or do both objects have to be dense?
Like this.
The star that ate a black hole.
Oh, the mass range on it, I don't know if LIGO detected it. I
doubt
think
it.
so, because
It's
it
too
wasn't in
slow
the
of a
paper.
merger.
Yeah, so that's the
it's
issue.
too slow of a merger.
They need to be faster mergers, and the black hole was slowed down because of the friction of being inside a star. So yeah, it really needs to be two black hole cores going boink.
Yep. Right, exactly. Yeah. Or in black hole and neutron star, or neutron star and neutron star, and so on. Those are all the questions that we had on YouTube. Are there any questions over on?
I'm seeing Hot Dog Wizard saying they're looking forward to getting the Patreon app. Broken Symmetry. Do the things we think are unlikely to happen because there are so many of these events in the universe? One out of so many happens often enough. Yes.
Yes.
The universe is vast, and given enough time, all the rare things get their opportunity to shine.
It really shows you, like, for example, how rare things like, say, Type 1a supernovae are. We know of about 2,000-ish that have happened in the last 30 years across, say, a volume of space that extends out to, say, 5 billion light years.
Yeah.
There's a lot of galaxies out there
that
these events happen once every, 10,000 years in a galaxy.
Yeah.
And so it has to be a very special sequence of events that makes one of these events happen. But because we can see so much of the universe, we see this stuff all over the place. Fast radio bursts, like we're detecting a few hundred, few thousand a year.
Those are super weird.
They're coming extremely long distances,
Yeah.
That they may very well be caused by magnetars that are consuming a planet, or who knows what they are, right? So,
Yeah, it's one
weird
of these
things happening very rarely.
And the more telescopes we build that are doing more things at more wavelengths, it's hitting the point where our main limitation is how fast can we process the data. The paper on the 30 solar mass star that ate its neighbor had a title that was not helpful. It was all about how AI discovered weird supernova, and what they meant was 80 some odd days after the Zwicky Transient Survey had detected the transient, a machine learning algorithm flagged it for follow-up, and yes, it was a super weird object. But it took 80 days or something around 80 days So it was super unpleasing at how much time it took to go from this set of information said, oh, there was a supernova. This set of things said, oh, it didn't behave. Yeah, it's all computers now, and they're not running fast enough, and they don't have enough training data. We are limited by our software.
Anything else?
I'm not seeing any other questions. I did see some snark about all the stories coming out about I3 Atlas. I will say that if you can weed successfully through the AI slop, there are images that were taken by, was it Curiosity or Percy? I think it was Curiosity of 3i Atlas, where they were able to stack enough images of the night sky that they can see the comet, which is nearing Mars.
Yeah, so that work was done by an amateur sort of citizen scientist,
Super cool.
Stefan Strauss, I think it is. And he, let me see, he did an amazing work to pull material out of
just publicly accessible data.
Yeah, just out of stuff from Curiosity. The problem is that the government shutdown has happened at exactly the time when you would be getting the data from the Mars Reconnaissance Orbiter. And so I can't imagine they didn't direct MRO to take its pictures.
I can.
But but nobody is fine. Yes, but nobody is updating the websites. So none of the data now are being put onto the website, which, is causing people to think conspiracy theories.
Yeah.
But
it's one of those things where we don't realize until it's too late what all is happening with the layoffs and the shutdowns with the last round of big JPL layoffs. They managed to lay off everyone who knew how to program one of the MRO instruments to do its job. And so like suddenly they're like, we don't have anyone that can direct the instrument anymore.
Yep.
And so they had to quickly retrain people and pull them off of other teams. And there are literally not enough people anymore at NASA to support all the instruments. And they did this on purpose.
Right. Yeah. Yeah. So, I mean, the deadline for things is going to be in, I think, like 2 days now.
Yeah.
But the government shut down. There doesn't seem to be any light at the end of the tunnel right now.
No.
So people are wondering if Juno has been shut down.
Yeah, I'll check with one of the team scientists later today.
Yeah, I think it's
The
unknown.
big concern is there's a suite of climate missions that Trump wants destroyed that without Congress to stop him, there's a good chance that these fully functional climate satellites are just going to get destroyed.
Olin Kulu asks, can the black hole be slowed down in the merger? Would be accelerated by stuff ahead of it. So I guess that's the
orbital
the one
decay. Yes,
Yeah.
The spin usually gets accelerated as it eats stuff.
Right.
So you have its physical motion does get slowed through interactions with all of the stuff around it, whereas its spin will often speed up.
And Arjun asks, do we have enough gravitational wave detector coverage to pinpoint the location of all possible black hole mergers that we can detect? Where do we need the next detector to increase accuracy?
We have greater than 3 now, so that does allow the needed...
4.
Yeah, and you only need 3 to get the entire sky.
Yep.
So now we have extra redundancy, which is good because it turns out mistakes happen. We're good. The biggest issue is one of sensitivity. What masses can you see with a given system? And this is where we're hoping to one day see LISA, which has been vaporware the entirety of my professional career.
LISA Well, not anymore. Lisa was, I mean, there was the Lisa Pathfinder. So they actually
Right.
flew a mission
It
to
was a
test all of the technologies
Pathfinder.
that are going to be required.
Yeah.
Yes. And about a year ago, they officially began the construction of the
Okay.
mission.
I
Yeah.
forgot that.
So
I
it's
probably
no
read
longer
it and then I
vaporware.
forgot.
Yeah.
Thank you.
Yeah. It's
His
actually
memory's
happening.
way better than mine.
But it's 2035, right?
Yeah.
Like we're still not going to see it launch for another decade, which is crazy. So yeah. But and then the other issue is the sensitivity on the distance. So right now the current crop of
Yeah.
gravitational wave detectors can only get you out to about, I forget, like 5 billion-ish light years, which is pretty amazing.
Yeah. Yeah.
But the next generation ones should take us right out to the very edge of the observable universe. So there's two in the works, one called the Einstein Telescope and the other one called the Cosmic Explorer.
Okay.
And those are going to have like 40 kilometer arms.
That's cool.
Yeah. Then sort of like two ideas. One is a triangle. One is sort of similar to LIGO. And so they will allow probably observations out to the edge of the observable universe and give you a better sensitivity into less massive black holes.
Yeah.
The challenge is with the bigger black holes, the more massive ones, you pretty much just can't do it from the surface of the Earth.
Right.
And so that's why we have Lisa. Lisa is the machine that's going to give us the mergers between supermassive black holes, which actually happen very slowly. And so
Yeah.
you get this very slow motion merger between the two black holes.
And I'm still just absolutely loving the work that they're doing with pulsar timing, where they're able to detect gravitational waves at cosmic scales.
Yeah.
It's not clean, it's not pretty, but
They're
it's
confirming
fascinating.
Yeah, I mean they're confirming their existence
Yeah.
in general, as they're not observing specific events,
Right.
but they are saying that yes, this kind of thing happens out there in the cosmos,
Yeah.
which is cool. All right, we've reached the end of our hour, so it's time to wrap things up. Thank you, everyone, for hanging out with us. Thanks in advance to everyone who's going to have to edit this nonsense. Thanks to the moderators, and thanks to you, Pamela.
Thank you, Fraser.
All right. I will be back at 5 o'clock for my weekly show.
All right.
We'll see you then.
I will be back at, math is hard. I will be back at 8 o'clock to do a makeup of our International Observe the Moon Night coverage, delayed by my airplane failure on Saturday. So when you're done with his Q&A, go grab some food, and I will be here
Nice timing.
to map the moon.